last time we talked about this new number e. We did some example problems, and I asked you guys to work on this worksheet 3. Before we get started with new stuff, are there any questions from this assignment that we want to talk about before we get going on new stuff?
Can you do number 3?
Sure. It says, under ideal conditions, the bacteria cells E. coli can double every 20 minutes. Suppose you start with 2 E. coli cells under ideal conditions. Write a model to describe the situation. So since this is a biological model, or biological situation where we're talking about a population, I'm going to be using my model with E in it. So the initial amount of cells did I tell you? Oh, 2. There it is. It's in there somewhere. And then E. And then the value for R here is going to be, if it's double, R should be 2. The thing to note here, though, T is basically these number of 20-minute segments. Since it's doubling every 20 minutes, if I'm going to put R down as 2, then I need to, the T needs to be in terms of those 20-minute segments, right? So if we ask how many E. coli cells will there be after 3 hours, 3 hours is 180 minutes, which is 9 of those 20-minute segments. So I'm going to plug in 9 for T. So, oh my gosh, so many. And then, so I'd write that number down, whatever that is. And then the number of segments, or how long to get to 120. Or to get to 1 million, excuse me. So I don't know, but that number that we just did for 9 was more than 1 million. So I'm just going to go 0 to 10. My minimum is 2. I'm just going to leave it at 0. And I need to be more than 1 million, so I'm just going to pick like 1.5 million. Let's take a look at a graph. Here's my 1 million. There's my growth curve. So this is the place that I'm looking for. So second trace, intersect command, enter, enter, enter. So about 6.6 of those 26, or those So 6.6 of those 20-minute segments. So if I take 6.6 and multiply by 20 minutes, I get 132 minutes. Okay with that? Okay. Anybody else on this assignment? Okay. Cool. Well, let's start with the new stuff for today. And what we're going to talk about today is this new thing called a logarithm. So, throughout our mathematics education, when we've introduced you guys to an operation, typically the inverse of that operation is followed shortly thereafter. So, early on we learned about addition, and the next thing we learned after that was subtraction. Next thing we learned about was multiplication. After that, we learned about division. We learned about, yes?
What is like the whole, this, like called again? Like the whole, you can always have like radical functions and like.
Talk about exponential and logarithmic functions. Then we talked about like specifically like squaring and square roots, or more generally like the nth power and an nth root. And what we're going to talk about today is we're going to talk about the exponential and its inverse, which is what we're going to call this logarithm. So let's kind of show you the motivation for kind of what's going on here. I know that 2 squared is 4, and I know 2 to the third is 8. But what power of 2 is going to give me, say, 6? What do you guys think? Just take a guess, right? There's no penalties for guessing. Would be a reasonable guess. Sure, 6 is halfway between 4 and 8. 2.5 is halfway between 2 and 3. But it's not quite enough, right? So, okay. Maybe we go a little bit higher. Maybe we try 2.75, right? And that was too much. So maybe we try like 2.6. That was still a little bit too much. So maybe we try 2.59. That's still a little bit too much. So, okay, maybe we do 2.58. And that's not enough. Okay, so maybe we do 2.585. And that's still too much. So maybe we try 2.584. Oops. 2 to the 2.584. And that's not quite enough. So we need a little bit more. And you keep on playing this game. Do you think you're ever going to come down to the number that makes this work? If we keep on going, you're going to find that we can't get a number that has like a finite number of decimal places to make that work. So anytime we think we've got it, we always have to we're going to be a little bit short or a little bit too much. So we're always going to have to keep on adding another decimal place, like we're doing now. So we can keep on going and going and going and trying to get there, but every time we do, we're going to get a little bit too much or a little bit too less. And that means that, what kind of number is this? If it has an infinite number of decimal places, and there's no pattern, it seems, in the decimals, this is some kind of irrational number, right? So we keep on doing this, trying to get exactly 6. We can't quite do it. It's always going to be either a little too much or a little too little, and we're kind of stuck here. So this question mark, well, this is about 2.58. But this is some kind of irrational number, right? That the decimals are just going to keep on coming and coming and coming with no kind of repeat pattern going on. So what we're looking for here is a name to kind of represent a number like this, right? Any other time we've run into an irrational number before, we haven't defaulted to the decimal expression. We give it a name, like we did for pi in geometry. We did for e yesterday. Or we did for square root of 2 or square root of 3 or square root of 5. These are all irrational numbers. They go on forever. Or even things like in trigonometry, like the sine of 60 degrees was an irrational number. This has happened to us many times. So the name we're going to give that, question mark, we call this the log base 2 of 6. This is basically the number we should say this is the exponent I'm going to use power of 2 that equals 6. So that's basically what that number is representing. So that's going to give us our definition for our logarithm. So if we have, say, b to the x is equal to y, that's equivalent to that value for x, that exponent we call log base b of y. So it's the power of b that gives us y, or that's equal to y. So, you know how like we can use our calculator to do like the square root of 2 or the square root of 3 or the square root of 5. We can use our calculator to find the decimal approximations for these logarithms. So let's show you how to do that. So on your calculator, if you press the math button and you scroll all the way down to the bottom, I'm just going to press the up arrow to get to the bottom of the list. You'll see a command called log base. If you pick that, it then is going to put this function onto your calculator. So if I wanted to know what log base 2 of 6 is, that was the number we were kind of searching for there a moment ago, I can type in the 2 for the base, that's the subscript, and then the 6 inside the parentheses, that's like the argument. And I press enter and out spits, you know, several decimals of that decimal approximation thing. Again, that's an irrational number, like pi, so it goes on forever, and there's no pattern to the way the decimals appear. Okay with that idea so far? So these logarithms are just the name that we give to an exponent, right? A certain exponent. So if I wanted to do in my calculator log base 3 of 10, I can go and press the math button, go down and select my log base option, type a 3 in my subscript, a 10 in my argument, and press enter. So that's about 2.096. And what this is telling me is that 3 to the 2.096 should be about 10. So the base on the logarithm is the base for the exponential. Argument in the logarithm is the solution to the exponential. And the solution to the logarithm is the exponent in the exponential. Now, some logarithms I could expect you to be able to do or to evaluate without having to use your calculator. Say, for example, I wanted to find log base 2 of 8. If I think about that answer as x, that's basically asking 2 to the x is equal to 8, or what power of 2 is equal to 8. And that's one that we should recognize, right? What power of 2 does give us 8? We've done enough prime factorizations in the last chapter to know this. Yeah, it's 3, right? Because 2 to the third is 8. So some of them, these logarithms, will be just regular old normal whole numbers, right? And those are things that we could conceivably do without a calculator. Everybody's okay with that idea? So I don't want to make it seem like all these logarithms are irrational numbers, but many of them are, most of them are. But if you pick the right things, you get like a normal whole number out of it. So some basic facts about logarithms. That if I take the logarithm of a non-positive number, or I should say of a non-positive number, that is undefined. So for example, if I wanted to do like log base 3 of negative 10, I tried typing that into my calculator. It's giving me this imaginary number. Probably for this chapter, you'd want to change your calculator back from complex mode to real mode so that you're just getting the error when you try to do that. We're not going to talk about logarithms giving us complex numbers in this class. It's beyond the scope of this class. So maybe we'll just say non-real. Be more technical there. Log base b of 1 is going to equal 0. Why is that true? Well, if I think about it using my definition of a logarithm, that's equivalent to saying b to the 0 is equal to 1, right? And that was one of our properties of exponents. So this is just, we know that that's true. That's a property of exponents. So log base b of 1 equals 0 is just the equivalent property of exponents as a logarithm, right? One more, log base b of b is equal to 1. Why is that true? Well, if I think about it, that's just saying that b to the first is equal to b. Well, of course that's true, right? Nothing shocking about that one. Now, it's a new notation that we're using, right, to kind of describe that, but saying log base b of b is equal to 1 is equivalent to just saying b to the first is equal to b, which is a No doy. So far, so good. Again, we haven't really done much yet. We've just kind of introduced this new operation and talked a little bit about how it works, how we can do it on our calculator, what it means, how we can do it by, in some cases, how we can do it by hand. Very important here is there's some notation involved. So we have two special logarithms that we write a little bit differently. So the first one is called the common logarithm. Which is log base 10. But we don't ever write the 10 there. We're going to write just log with no subscript at all. So when there's no subscript on your logarithm, we understand the base to be 10. It's not 1, it's not 2, it's 10. Everybody okay with that? Really critically important, because you're going to see that pop up rather frequently in homeworks and things. So you got to make sure that you know that when there's no subscript, that means that the base of the logarithm is 10. Okay? The other special logarithm is called the natural logarithm. And that's log base. So this happens since I've gotten this new tablet. This has been happening to me rather frequently, where like OneNote just freezes on me. So periodically I just had to come in and like close out OneNote and restart it. And I don't understand why it gets why it's freezing, but it's rather irritating. Anybody knows what's going on. Oh, I did it again. But I can't do anything inside of OneNote. And it's doing this. I don't know why it's being a duty head. You know? Maybe it's this. So the other one we said was the natural logarithm. That's log base e. Remember, e is that number we talked about yesterday, about 2.7128, or 1828, excuse me. But we don't write log base e. We're going to write ln. So when you see ln, you need to recognize that as log base e. The base of that logarithm is that number e. Just as a, I don't know, I think to help you guys more than anything else, you'll notice that when I'm writing my logarithms that I'm using cursive to write the logarithm part. I would strongly encourage you guys when you're doing your own work and writing on your own paper to do the same thing. The reason I say that is that if you write log like this, I've seen many students turn that into 10g times 10 and just write like, oh, that's 100g, and then I can divide by 100. Like, you get confused about the L's and the O's being ones and zeros and things. So please, I would encourage you to write it in cursive so you don't accidentally turn those into numbers and start doing weird stuff to me. it's an easy thing to do, or it's a common thing to do. I guess I wouldn't say it's easy, but it's common, and I don't want to see you guys make those same kind of mistakes. So I would strongly encourage you, even if you don't really know how to write cursive, we're talking about 4 letters, and L and O and G and an N, that you got to figure out the cursive for. And it's not so bad. And even if it's just kind of like a messy cursive, like mine is kind of messy, you look at that thing and you're like, what the heck is that? And it's like, as long as I can tell there's an L at the start of it, and the next letter is either OG or an N, I can figure it out. So even if it's not super pretty, that's okay with me. The point is just trying to not make it look like a 10G or 1N or something. Is that okay? I know that's a weird thing to kind of stop abruptly, but I just thought of it. It's one of those that I've seen it in the past be issues, so I wanted to make sure that we talked about that. Okay. So the biggest idea here that we want for today is that like log base b cancels exponent base b, and similarly exponent base b cancels log base b. This is the big takeaway from here. Like, you will not be able to figure out any of the solving if we don't kind of internalize this concept. So just like addition cancels out subtraction, or division cancels out multiplication, or a square root cancels out a squared, we're going to use logs and exponent bases to cancel each other out. So, for example, if I have 2 to the log base 2 of x, that exponent base 2 will cancel that log base 2. And we'd be left with just x. So note that if I have 2 times log base 2, nothing happens. That multiplying by 2 and having the logarithm and the exponent are 2 different things, right? Like 2 times 3 is not the same thing as like 2 to the 3rd, right? So multiplying by 2 is not the same as having like an exponent base of 2. And then let's say we had log base 2 of 2 to the x. Here the same thing would happen, is that the log base 2 would cancel the exponent base 2. So we'd be left with just the stuff in the exponent. I want to point out to you guys that in this case, the parenthesis here is not multiplication. We're not multiplying log 2 times 2 to the x. And in fact, that makes about as much sense as square root symbol times 7. Be like equivalent to writing something like this, which makes not a bit of sense at all. Logarithm is an operation, it's not a variable, it's not a number. It's just the name of an operation. It would be like saying, oh, I'm going to multiply by square root symbol, which I don't think any of us would do. That doesn't make a lick of sense at all, right? Again, I know that the notation in this chapter and this logarithm notation can be a little bit challenging, and that's why I'm really spending some time and hoping to clarify what we mean when we write these symbols and some of these common misconceptions that I see. All right. Let's look at finding some inverse functions. So this was something that we've done in first semester. So let's say that we wanted to find the inverse of y equals 2x plus 5. The idea here is to get the x by itself and then to swap the x and y variables. So what would we want to do first to get that x by itself? Nothing tricky here. Yeah, subtract 5 from both sides. That's right. So I can't subtract 5 from a variable, so I just have to write it next to each other. And then we would divide by what? 2. Yeah. So that's going to get the x by itself. So the last thing we would do is we just swap the x and the y. And there's our inverse. Everybody okay there? So that was a skill we would have practiced in first semester rather early on. Let's do another example of this, but this time let's use like an exponential function. So let's say we have y equals 2 times 3 to the x plus 4. I guess here's my first question. Can I just multiply the 2 and 3 together and call that 6 to the x? Absolutely not. Remember, there's 2 ways that we can multiply exponentials. So if I have like x to the a times x to the b, where the bases are the same, I can multiply them together by adding exponents. Or say I have like x to the a times y to the a. I can multiply the x and y together and keep the exponent the same. But I can only multiply things together if they either have the same base, which I add the exponents, or the same exponent, in which case I multiply the bases. Here, the exponent on the 2 is a 1. The exponent on the 3 is an x, so they don't have the same exponent. And clearly the bases are different. One is a 2 and the other is a 3. So those cannot be multiplied together. I just wanted to really iterate that. Because again, that's a common mistake I see students make. Okay, so again, we're trying to get the x by itself. What would be the first thing we'd want to do here? Subtract 4 from both sides. Same idea that we did before, right? It's basically still the same first step. Okay, that's good. And then what? Okay, get the 2 on the other side. How am I going to get the 2 over there? Is the 2 being added? Let's divide it, because the 2 is being multiplied, right? Everybody's okay with that notion? Everybody's okay with that? Now, how am I going to get rid of that exponent base of 3? What is going to cancel out that 3? Can I divide by 3? Is that going to cancel it out? Nope. Because it's not multiplication going on between the 3 and the x. But do you see that? So what operation is going to cancel that 3 out? It's a logarithm. Which logarithm do I want to use? Log base what number? 3. Why 3? Because it's the same base as the exponential. Okay. So we're going to do log base 3 to both sides. Because the log base 3 cancels the exponent base 3. And we're left with just the x on that right-hand side. And then we just swap the x and y variables. Everybody okay with that idea? This would be my final. Let's do one more. But this time, let's have a logarithmic equation. So what should we do first to get the x by itself? Good. Next, what should we do? Divide both sides by 2. Very good. Okay. Everybody so far so good? Now, how do we get rid of that ln? Can I just divide both sides by ln to get rid of it? No. Remember, ln isn't a number. It's an operation. That'd be saying like, oh, I'm going to divide by square root symbol. Right? What's going to cancel out the ln? Close. ln is a logarithm, so a logarithm won't cancel out another logarithm. But remember, logarithms cancel out exponent bases. So to cancel out a logarithm, we're going to use an exponent base. So which exponent base should I use? I want to use the same base as the base on the logarithm. What was the base for ln? Remember, this was one of those special short or abbreviations that we needed to make sure we memorized. We scroll back. ln was the same as log base e. Everybody okay there? Again, gotta make sure you have those two special logarithms memorized. You need to know what their bases are when you see it written down on a sheet of paper. So to cancel out this logarithm, this ln, I'm going to use the exponent base e. And I'm going to write that absurdly large because I don't want anybody to confuse this exponent base with multiplication, right? I don't want it to look like I'm multiplying both sides by e. I want it to look like an exponent base. And as we've discussed previously, that exponent base is going to cancel the logarithm. And I'm left with the x minus 1 that was inside the logarithm. So to finish her up, what do I have to still do? notice the x isn't by itself yet. So we still need to add 1 to both sides. And I can't add 1 to e to some power. So I'm just going to write it next to each other. And then we switch the x's and y's. And that's my final answer. So, in summary, what I'm going to ask you to do in your homework is be able to use your calculator to do things like log base 5 of 7. So you should be able to type that into your calculator and come up with the answer. I'm going to ask you to convert between exponential and logarithmic form. So, for example, if I have like x equals log base 2 of 8, you should be able to rewrite that in exponential form, saying 2 to the x is equal to 8. Or I could give you something in the exponential form. Like 5 to the third is equal to x. And you should be able to convert that into the logarithmic form. And I'm going to ask you to simplify. So maybe I'll give you something like log of 10 to the third. So remember that when we write log with no subscript, what is the subscript really there? It was 10. Remember, this is one of our other special situation. So notice the base of the logarithm matches the base of the number, or the base of the exponential. So we can just simplify that down to be 3. Everybody okay with that? Or I might write something like this. So here I have an exponent 2, and in its exponent is log base 2. So those can cancel out. And we'd be left with just whatever's in the exponent. Everybody okay there? And the last thing I'm going to ask you to do in the homework is be able to find some inverses. And that would be just like the last 3 examples that we did. Everybody okay with that idea? So that's the things I'm going to ask you to do in the homework. Nothing super duper complicated. The last skill there that we spent the most time on, I think, is the most complicated skill. But these other ones are important, like foundational things that help a lot as we move forward here. So we still have, I don't know, 3 or 4 more lessons this chapter. So we'll be still working through this week and into next week to finish this thing up. This will probably be the last test of the year before the exam, depending on what the exam format is supposed to be looking like. They haven't told us what the exam schedule is or what we're doing for those days or whatever. I don't even. So when I know, I'll tell you guys what the plan is and what my plan is in terms of writing a final. And indeed, we're going to have one. But this will be the last chapter test. Anything we do after this, my plan would be like to put it only on the final. So any material we cover after we finish this topic, I wouldn't have a test for. I would just put the topics on the final, rather than trying to cram another test in before the end of the year. Andrew?
Is the final going to be like